Every large language model you have ever used, ChatGPT, Gemini, Claude, Grok, was trained on hardware built by one company. Every self-driving car computing its next move, every AI image generator rendering a face, every hospital scanning system detecting a tumor with machine learning, all of it runs in some way through silicon designed by the same company. That company didn't set out to build the infrastructure of artificial intelligence. It set out to make video games look better. This is the story of NVIDIA and the decade-long unwanted bet that turned a graphics card maker into the kingmaker of the entire AI industry.
In late 1992, 3 engineers sat in a booth at a Denny's diner on Berryessa Road in San Jose, California. Jensen Huang, an electrical engineer who had once worked as a dishwasher and busboy at that very chain of restaurants, Chris Malachowski, an engineer from Sun Microsystems, and Curtis Preem, a graphics chip designer who had worked at IBM and Sun. None of them were rich, none of them had a guaranteed customer. What they had was a bet that as computers got more powerful, people would want richer, more realistic graphics, and that this would require a dedicated chip separate from the computer's main processor, built only to handle visuals. They founded NVIDIA on April 5, 1993. For years, the company built graphics chips for a niche and brutally competitive PC gaming market, fighting for survival against dozens of rivals, 3DFX, S3, Matrox, ATI, most of which no longer exist. The margins were thin, the product cycles were brutal, and more than once the company came close to running out of cash before a new chip shipped. In 1999, NVIDIA went public at $12 a share, crossing $1 billion in market value within months. That same year, it released the GeForce 256, a chip the company marketed as the world's first GPU, a graphics processing unit. It was a good product in a small industry, competing for the attention of gamers and PC hobbyists. Nobody, including NVIDIA, believed it was about to become the backbone of a technological revolution that had nothing to do with video games.
Here is the detail almost nobody outside the chip industry understood at the time. A GPU is built differently from the processor in your laptop. A regular processor does a few things very fast, one after another. A GPU does thousands of simple calculations at the exact same time, because rendering a video game means calculating the color and position of millions of pixels simultaneously. That architecture, built purely to draw video games faster, turned out to be almost perfectly suited to something engineers hadn't even fully defined yet: training artificial neural networks, which are also, fundamentally, millions of simple calculations happening at once. In 2006, Jensen Huang made the decision that defined the next 20 years of the company. NVIDIA unveiled CUDA, a software platform that let outside developers, for the first time, program NVIDIA's graphics chips to do general-purpose computing, not just render games. It meant scientists, researchers, anyone could use a $500 gaming chip to run massive parallel calculations that used to require supercomputers. The market's response was brutal. Wall Street didn't understand what problem this solved. NVIDIA was raising the cost of every chip it shipped to fund software nobody had asked for, and a research bet with no clear customer. The company's valuation collapsed from roughly $12 billion down to somewhere between $2 and $3 billion. Employees watched their stock options become worthless. Analysts openly questioned whether Huang had lost focus on the gaming business that had built the company in the first place. For years, CUDA looked like the mistake that would sink the company, a vanity science project bolted onto a hardware business that didn't need it.
But Huang kept funding it. Every single GPU NVIDIA shipped, even ones going into ordinary gaming PCs, came with CUDA built in. Slowly, a small community of scientists and researchers, mostly unnoticed by Wall Street, started using these chips to accelerate their work. Then, in 2012, everything changed. A team at the University of Toronto built a neural network called AlexNet to compete in an image recognition competition. AlexNet didn't just win, it demolished the competition, cutting the error rate almost in half compared to anything built before it. It had been trained using 2 NVIDIA gaming GPUs and, crucially, CUDA. That single research result is now widely credited as the spark that ignited the modern deep learning boom. Over the following decade, every major advance in AI, image recognition, natural language processing, and eventually large language models, was built on the same foundation: NVIDIA GPUs programmed through CUDA. By the time the rest of the world noticed AI was becoming a big deal, researchers everywhere had already spent close to a decade building their entire tool chains, libraries, and institutional knowledge around NVIDIA's platform. Switching away wasn't just expensive, it meant rewriting years of code and retraining armies of engineers. NVIDIA hadn't just sold hardware, it had quietly built the entire language that AI research spoke.
For years, this dominance stayed mostly invisible to the public. Then, in November 2022, OpenAI released ChatGPT. Within months, it became one of the fastest-growing consumer products in history, and every technology company on the planet, Microsoft, Google, Meta, Amazon, and thousands of startups, scrambled to build their own AI systems as fast as possible. There was only one place to buy the chips capable of training these systems at scale, and it was NVIDIA. The financial numbers that followed are almost unbelievable. NVIDIA's data center revenue, the part of the business selling AI chips to cloud providers, went from roughly $15 billion in fiscal 2023 to over $47 billion the following year, an increase of more than 200%. By fiscal 2025, that single division alone was generating more than $115 billion. Quarterly revenue that used to be measured in single-digit billions was now measured in the tens of billions, quarter after quarter, growing by triple-digit percentages for 5 straight quarters. The stock market's reaction rewrote the record books. NVIDIA crossed $1 trillion in market value in mid-2023. It hit $2 trillion just over 8 months later, in February 2024. It reached $3 trillion only about 100 days after that. By July 2025, it became the first publicly traded company in history to cross $4 trillion. And in October 2025, it became the first company ever to cross $5 trillion, a milestone that took the company roughly 30 years to build, and then only about 100 days to leap into once the AI boom fully arrived.
What makes NVIDIA different from every previous dominant tech hardware company is that its power isn't just about having the fastest chip. Competitors have, at times, built chips with comparable raw performance on paper. NVIDIA's real moat is CUDA, the same unwanted bet from 2006. 2 decades of accumulated software, libraries, developer tools, and trained engineers all speak that language. By the platform's own count, it now underpins hundreds of software libraries, thousands of accelerated applications, and a developer base in the millions, spread across tens of thousands of companies that have built their AI infrastructure directly on top of it. Ripping it out doesn't just mean buying a different chip. It means rewriting code, retraining engineering teams, and rebuilding an entire technical foundation most companies simply can't afford to redo on a reasonable timeline. That combination, best-in-class hardware plus an entrenched software ecosystem nobody else has replicated at scale, is what lets NVIDIA behave less like a chip vendor and more like a kingmaker, deciding, in effect, who gets enough compute to compete in AI at all.
No empire is without pressure. NVIDIA's dominance, once close to a near-total monopoly on AI training chips, has started to erode, slowly but visibly. AMD has been steadily gaining ground with its own AI accelerators. More significantly, the very companies that are NVIDIA's biggest customers, Google, Amazon, Microsoft, and Meta, have all begun building their own custom AI chips, specifically to reduce their dependence on NVIDIA for at least part of their workloads. Analysts now estimate NVIDIA's share of the AI accelerator market has slipped from a near-total monopoly a few years ago to somewhere in the 70s to 80% range, still commanding, but no longer absolute. Geopolitics has added another layer of pressure.
Because these chips are considered strategically critical, the US government has repeatedly restricted NVIDIA's ability to sell its most advanced AI chips to China, reversing and re-reversing policy multiple times through 2025 and into 2026, at one point costing the company billions in canceled orders in a single quarter. In early 2025, a Chinese AI lab called DeepSeek shook global markets by releasing a highly capable AI model that it claimed was trained far more cheaply than expected, briefly raising fears that the AI industry might need far fewer NVIDIA chips than assumed. The moment passed, but it was a preview of the kind of shock that could someday challenge the company's grip.
Jensen Huang, still CEO more than 3 decades after that meeting at Denny's, now talks about NVIDIA's future in terms far bigger than chatbots. He describes a shift toward what he calls physical AI, robotics, self-driving vehicles, and autonomous systems that need the same parallel computing power that once only rendered video games. He talks about humanoid robots folding laundry and moving boxes in warehouses, using the same underlying chips that train today's chatbots, and about factories that simulate an entire assembly line inside a computer before a single robot arm is built. Nations are now racing to build their own sovereign AI infrastructure, treating compute capacity the way earlier eras treated oil reserves or steel production, and NVIDIA hardware sits at the center of nearly all of it. The company that once bet everything on an unwanted piece of software is now betting that the next decade of automation, robotics, and physical intelligence will need it just as much as the last decade of chatbots did. If that bet plays out the way the CUDA bet did, the next $1 trillion of value created in this industry may look less like a chatbot subscription and more like a warehouse full of machines that never existed before.
The lesson underneath NVIDIA's rise isn't really about chips. It's about what happens when a company makes a bet the market hates, funds it anyway for a decade with no guaranteed payoff, and ends up owning the foundation an entire new industry is built on. NVIDIA didn't predict the AI boom. It built the only tool capable of creating one, and then waited. Whether that kind of patient, unwanted bet can happen again, inside NVIDIA or somewhere else entirely, may end up deciding who holds power in the next technological era. NVIDIA didn't predict the AI revolution. It spent a decade building the only tool that could create one. If a story like this is worth understanding, subscribe, because we're going to keep tracing the hidden decisions behind the technology reshaping the world. And drop a comment. Do you think NVIDIA's grip on AI lasts another decade? Or does the next Kingmaker come from somewhere nobody's watching yet?